And again, thank you all for joining us here. What me and Trey are going to cover today are how we accomplished virtualizing the post-production edit systems we use at Warner Brothers Discovery. You haven't noticed there was a pandemic a few years ago, and that kind of put a wrench in people coming in and using these high-performance edit bays and solutions that we had on site. So again, we had to figure out a way and scramble to get that out to these editors to work from home. And what became a POC that we had just in time, ready to go for the pandemic, became a full-fledged production system for CNN and studios. We're going to primarily be covering our studios deployment, since it's kind of a bigger, beefier, more integrated system between CNN and studios. So, Trey, I think you're controlling the slides. You want to hit the next one for me?
I gotcha.
And this is kind of a little bit of agenda that we're going to go over. We did our introductions. We're going to go over kind of our use cases. We're going to actually describe what a hypervisor is. That is basically the bare metal and the bones that makes all this work. It's how we virtualize everything. Next, we're going to go over the VMware Horizons tech stack, and we'll explain to you why we chose Horizons and what it does for us and all the interworking parts. Then we're going to go over how studios, how we designed our system at studios. Some of the key features, system design, system specs, all that fun stuff, and how that interoperates and works together. Then we're going to go over pretty much a key portion of it is imaging and that software deployment scheme that we use to keep the images and the systems up to date, and the platform we give the editors to work with. And then we'll go into a kind of fairly quick live demo afterwards to show you how easy it is to get on, to get working, and start editing from anywhere in the world. Trey, you want to hit the next slide for me? Oh, and after that, QA. If anyone has any questions, and feel free to ask questions as they come up. So what we had to figure out how to solve, we had to make sure, and we had to give the editors a way to work outside the office and on the road with the same consistency and the same experience. We needed to give the editors a low latency edit experience. We can't work in a nearline editor and have choppy and laggy playback. It has to be like operating inside the building in front of a physical machine. And we had to figure out how to do that for the end editors. We had to make sure that it was secure. We can't really transfer files and proprietary data and video over a public network, the internet. How do we give the editors the same media and the folder structure and the tools and delivery systems that they had with this new system? And how do we manage a shared tool now? So we went from individual workstations to basically a full circle back to mainframe type systems. It's these things that we're using now might as well be dumb terminals. If you want to think about it nowadays, they're headless. They connect into a server back on site, back on prem. Trey, you want to hit the next one for me? So the old way we used to do things is we had a edit bay. We had a 2013 Mac Pro cylinder, which I love to refer to as Trash Pros. All of our edit bays were fiber channel connected to the SANs on the back end. When we had to do updates, they were slow. We either pushed them with Jamf for little small package updates, and if we had to do a major update like an OS release, we had to hit every single edit bay by hand. And that was extremely time consuming. Also, the edit bays were static. So if I had an entertainment editor, they couldn't go into a sports bay and work. And God forbid something happened at the CNN center and a CNN editor had to come over and work. There wasn't any of the software they needed to work in any of the studio's bays whatsoever. Next one for me, Trey. So with VDI, we enabled our workflow to switch over to these flexible bays. Any bay can now do any workstation. VDI introduced a dynamic way for imaging and updates, and it can be handled with a lot smaller engineering footprint. Trey, you're managing about 187 machines right now and you can get new image deployments out in less than an hour from pretty much start to finish. We simplified our storage fabric. So no longer do we have a monolithic storage platform with thousands of zones. And I don't know if any of y'all have ever done a fiber channel configuration. There's a lot of point-to-point configuration that was really, really complex and cumbersome. Troubleshooting got easier for us. Let's say an editor had a problem with their edit station. We would have to go and fix it. Now with VDI, we tell an editor, hey, reboot your machine. You're going to grab a brand new machine in a pool, and you can keep working while engineer now takes that bad one offline to troubleshoot and rebuild it. We also got a hell of a lot more density out of these things. So we are running 180 servers, and we're only using 180 virtual machines, and we're only using 12 servers. The power savings alone from that and the footprint is incredibly small compared to what it used to be with all those big Z8s or Mac Pros that we had. We're using high performance protocols with these now. So we'll go over the differences between Teradici, or what Teradici offers, which is PC over IP. We'll go over what VMware offers, which is Blast Extreme. And all this is encrypted. And the only thing you're sending with these protocols are video, mouse, and keyboard movements. So it's super secure for all of our editors. We also give them a consistent login experience. So no matter where you are, no matter what you do, you're going to log in the same way, and it makes it easier and less questions for the editors to have when they're working remotely or on site. We also gained the ability to roam user home profiles and application settings with VDI. So when we do a major update, there's a lot less downtime for the editor, since all their preferences go wherever they go, and they're saved and backed up. And now we have external gateways. So no longer do editors have to get on with the VPN, which can be slow and cumbersome. And VPNs, it's a dedicated kind of pipe that you have to use. So if a user was downloading a massive video file over the VPN, it's possible they were affecting everybody else on the network. Now we have these special appliances called UAGs, and they're dedicated for just VDI. Excuse me. But we're going to kind of start with the basics. What is a hypervisor? A hypervisor is the software that runs all of our virtual machines. The one we use is from VMware. It's called ESXi. We'll go into a little more details about that later. A hypervisor creates a virtualization layer, and it makes virtual processors, RAM, and other resources for the virtual machines. The actual server, or the thing running the hypervisor, is called a host. So you might refer or hear me say host later on. That's what I'm talking about. And the virtual machines that live inside the hypervisor are called guests. You want to hit the next one for me, Trey? Now, some of the benefits of a hypervisor are I can install a whole bunch of different virtual machines with different operating systems and run them simultaneously. I can consolidate workflows. And I have an optimization of physical resources with these. So back in the old school days, okay, I had a edit bay. And maybe 2% of the time, it was actually using 100% of its power when a machine was rendering. Otherwise, it's just set idle and unused. Now with this hypervisor, I can put 20 machines on one machine, and now I can take full utilization of all the resources a machine has to offer. It's also scalable. It's super easy just to purchase another server and put it into the stack and instantly gain 20 more edit stations. Now, there's two different kinds of hypervisors. The one we use is a type 1 hypervisor, and ours is from VMware. It's called ESXi. Citrix Zen Server would be a competitor to them. Type 1 hypervisor is installed directly to the server. It's your best performing out of the two. It also does migrations for you. So if I need to do maintenance on a server in motion while working, I can move a VM from one hypervisor to another with the scheduling software that sits on top. It allows direct access also to hardware that's in the server. And we'll talk about that a little bit later. But we actually virtualize GPUs. And we have a whole bunch of GPUs in each one of these servers for all of our editing systems. Now, type 2 hypervisor is like a VMware workstation or a virtual box. They run on top of a already installed OS like Windows. They don't require really a management console or like a vCenter server to manage them. They're super convenient for testing. I was showing Jack a little earlier and Matt how we're doing our DevOps now with type 1 hypervisors. They're lower performance, but a lot of them are free. So you can get like VirtualBox for free and start testing and doing making virtual machines on your local machine right now today. VMware Horizons is our software that we use. And this is kind of a crazy picture, but we can go over the flow from right to left. So we have users, clients entering from the public internet. They hit a load balancer on the DMZ, and they access something called a UAG, a Unified Access Gateway. This tunnels all the traffic securely in and out of the building. Then they go over to the next stage, and that's where our connection servers live, and they handle the brokering of the connections. They basically say, okay, you have permissions, the user logging in. It checks based on AD. It goes and finds which desktop or virtual machine is available. And then it says, all right, user, go connect here, and this is how you're going to get there. And all that on the other side is just kind of the back end, talks about the images and all the supporting servers that we have. Trey, you want to hit the next one? We're going to go to each one of these a little bit more in details too. So what is VMware Horizons? Well, it is our virtualization software product for delivering desktops and apps on Windows, Linux, and Mac. It enables us to really streamline our imaging process and our connection process for the end users. It also allows for streaming apps. So I can give a user a virtual machine, so a full desktop experience, or I can just stream a app to them. Like if I have to use a legacy version of Firefox or one of our old digital delivery systems, I can have that app isolated and send them that app interface, kind of like what we're doing for this presentation here. Like WebEx chooses to send a PowerPoint. I do that for the end user for certain applications. We're not currently doing a flexible or hybrid, but VMware Horizons allows us to burst into the cloud and spin virtual machines up into AWS or Microsoft's Azure platform as well, if we wanted to or needed to. There's a few different components of VMware Horizons. We have the ESXi server, which is our hypervisor that actually runs all the virtual machines. We have VMware vCenter. That's the orchestrator, and that's the kind of commander. That's what all the EXI servers hook into, and we use vCenter to manage them all. VMware Horizon connection servers, we have two different kinds of those. We have the connection brokers. These handle authentication and brokering the connections out to the virtual machines. And the unified access gateways sit on the DMZ. They tunnel external connections in, and they can also tunnel external or private connections inside the building. So if you have an air-gapped edit network for security reasons, you can get into those networks securely from anywhere in the building as well. The VMware View Agent is the actual software installed on each VM, and that basically communicates with the connection broker, lets you know it's available. It has all the protocol software built into it and installed on it, and it handles the communication. The VMware Horizon client is a physical piece of software that you have and that the users use to get into the system. And the View Administrator is how we manage everything on the back end. Now, we talked a little bit about hypervisors. Let's talk a little bit more about ESXi, the one we're using in production. It's a type 1 hypervisor. Sometimes it's called vSphere. It has a really, really small footprint. It's only about 150 megs to install on each server. It's responsible for creating snapshots and performing vMotions and all the back-end stuff that we need to run these virtual machines. It also can provide us a console for directly viewing and managing the VMs. There's a little asterisk on that. It doesn't work with virtual GPUs like we're using, but you do have the ability if you remove that GPU. It also does DRS for us. DRS is an automated system for load balancing machines. So if ESXi kind of sees, okay, this server is working really, really, really hard, and this server over here is sitting idle, it can, without us intertwining or working, move machines around. It also includes or handles the vGPU drivers we're using for all these NVIDIA graphics cards that we attach to the virtual machines. Next is the vCenter server. It's the centralized management for all of the ESXi hosts. In here, we create clusters of hosts and we basically glue everything together. It's also where we do our backend networking and we apply it to the servers. These are called distributed virtual switches. Like you can pipe in a whole bunch of different networks into these and tag them based on VLANs and have access to your entire company's network if you just trunk those in on a switch level. We don't do too much of that because there's no need for it, but that's how a kind of an IT-based vCenter would work. It also stores and hosts all of our image templates, which is really important. And it has the profiles for them, where we basically tell it how to provision when we are launching and deploying machines out. It also has an API engine built into it. So we connect all of our monitoring to vCenter. And it also connects to Horizons with these APIs to build machines and destroy machines. Here's a little snapshot of vCenter for us. We can see on the left-hand side, it's what's called a data center and a cluster. And going down are the hosts, and then the virtual machines have little green arrows for it. Our cluster has 3.2 terahertz of power, and we have almost, I want to say 18 terabytes of RAM installed on these 12 machines split between them. You want to hit the next one for me, Trey? VMware Horizon connection servers. There's two kinds again, the connection broker and the unified access gateway. The connection broker is responsible for authenticating users. It checks on AD based on this. You have to have two or more. They replicate between them, and if one goes down and you have a load balancer on top, they'll automatically pick up and keep going. Servers must be close to each other. That's one of the learning lessons we found very early on when we started deploying machines up in Hudson Yards. They need to be inside the same data center, or things are out of spec and they won't work quite right. Users connect to these connection brokers if they're internal and they don't need to use a UAG. They automatically back up and replicate to their peers. So you can make a change on one, it automatically is going to make those changes on the peer connection brokers. Here's kind of a flow of how a connection broker works. We'll start with a little green guy on the left. They log into the connection server when they're on site. It authenticates them. And then the connection broker tells that client what protocol to use and which virtual machine to connect to. It does not tunnel any traffic through it. The unified access gateways are for tunneling traffic externally or into private networks. They are a hardened Linux appliance. It's a download we get from VMware, and it's super easy to install. It's a few button clicks. You put in the configuration, and you deploy it out to a virtual machine, as a virtual machine. It acts as a proxy for connections inside private and trusted networks. All traffic is tunneled through a UAG and is encrypted. All traffic is encrypted, and we store all of our trust certificates. We're using SSL to encrypt this data on the network. A UAG needs to peer with a connection broker. It does not handle any kind of authentication needs. That's why it needs that connection broker. It also communicates with two-factor authentication solutions like Okta or Radius, which you definitely want to use. Here's kind of a flow on how a UAG works. You have your client on the outside, like the internet. You tell it to connect to a UAG. It authenticates against a connection server, and that talks to Active Directory to see if it's allowed. And then the UAG or the connection broker tells the client to go through the UAG and access its virtual machine inside the network. Now, the VMware View Agent is that piece of software that we install, and it communicates with the connection broker. That's on all of our virtual machines. You can also put that on physical machines and use the same infrastructure for connecting to physical machines outside your network, much like the virtual machines. It provides connection monitoring, virtual printing, allows for connections to USB devices. It can also do folder sharing for us. It contains the VMware Blast and PC over IP software, which are our kind of protocols that we use to send out the display. And we'll talk about those a little bit later. The Horizon client is the software that you use as an end user to get into the system. It runs on anything. It can be Windows, Linux, iPhone, Android, OS. I can't tell you how many times during the pandemic I was on the road, got a phone call for support, scrambling. Oh, I don't have a computer in front of me. I got on my cell phone. I did my administrative work and I got my job done. Can connect to a UAG or a connection broker. It decodes H.264, H.265, or PC over IP, and it also does drive sharing and USB device redirection. So if a user has a Wacom tablet, like a lot of artists like to use for Photoshop or Premiere, it helps with that and can facilitate that to the virtual machine. It can also do the color correction wheels for color graders. Sometimes this is referred to a software client. Here's kind of an example of what you would see if you logged in when you log in with the client. You see all your pools up at the top. Those are all your physical virtual machines. And down at the bottom are applications you can stream. So if I were to click a application, I would just get that Firefox window to pop up for me. If I click a pool, I would get a physical desktop to appear for me with all the applications and whatnot. VMware View Administrator is how we manage everything. It is a web-based administrator. There are no thick clients for it anymore. We use this to create virtual desktop and application pools. That's what we just saw beforehand. This is also where you assign permissions or entitlements for users to connect to these pools. It is installed as part of the connection broker install process. So when you install a connection broker to a server, you also get this administration webpage. Any changes you make are automatically replicated, system monitoring, and you set all your global settings for your servers in here as well. Here's kind of a little example of what that administrator page looks like. I can kind of see what's going on. I get a snapshot, errors, how many current sessions I have. And if y'all want, we can dive into this a little bit more granular later, but this is where we actually deploy our pools out and do all the configuration with them as well. Horizon imaging and desktop protocols. I know this is going to get a little wordy, so I'm going to go pretty quick on these. So there are three types of image pools you can make when making virtual desktops. You can do a full clone, which is a full virtual machine. You can do a link clone, which is a copy of a virtual machine and managed with View Composer. This is actually depreciated coming up with the latest version of VMware Horizon, the VM Horizon software. They're favoring instant clones now. Instant clones run a copy of a virtual machine that uses the same memory as the parent. It does like a copy on write kind of technology that they have. So it's kind of like a container per se, where you're kind of spinning up more memory as you need it to. We don't do any instant clones. I honestly don't know too much about it. We experimented with them very early on, and they didn't have the speed or the performance we needed for editing. We only use full clones at studios. So here's kind of an example of a imaging process that we would take from start to finish. So we have to make a Windows image, and we turn it into something called a gold image that has all the Horizon agent installed, all the VMware tools installed, all the drivers installed for the graphics cards, and a suite of base apps. Well, we gold that out. We make sure it's absolutely perfect, and then we make a copy of it, and we install all of our applications like Premiere, like Strawberry, which is our PAM. Then we push that out to a VMware Horizon pool, and that allows us to connect to it with the protocols. We test it, we SAT it, we UAT it, and then we have the editors do the exact same thing and all the exact same testing we did before we put the image in production. And this loop is basically a CI/CD loop where we get constant feedback from the customers from testing UAT and throughout the processes, or during software updates. We'll take all that back, we'll open up that base template, we'll make the changes, and we'll go through the process again. So we have 3 different protocols. VMware Horizon uses 2 of these. So VMware makes something called Blast Extreme. They developed this to compete with Teradici's PC over IP. It's based on H.264. It can use H.265 now. It's GPU based and supported encoding. Uses a lot less bandwidth than PC over IP. It's a lot less susceptible to packet loss and latency. That's really good if you're working on a bad connection, bad Wi-Fi, or you're a long distance away from the servers you want to connect to. It's supported by VMware Horizons. Now, the original PC over IP uses CPU-based encoding. It allows for lossless video support. We found that PC over IP has a lot better audio sync than Blast does, and that was super important for our end users when they were trying to sync up timelines in the NLE in Premiere and just hit those tempos and those beats just right. It's overall sharper, like the text sharpness that's a lot better with the PC over IP protocol. It's also supported by VMware Horizons, but it does have some limitations. The max display resolution we can use is 2560 by 1440 with the Terra 2 Zero clients, and we'll talk a little bit about Zero clients here in a second. And Teradici's newest and latest is PC over IP Ultra. Now, that's not included with Horizons. VMware and HP now that owns Teradici are trying to work out a deal where we could get Ultra installed as part of our package. But those support 4K monitors now. For their CPU-based encoding, they use an instruction set right on the CPU's AVX2 for a much faster encoding. They also can do GPU encoding if a GPU is present now, and GPU decoding on the end user's machine. Again, not currently supported by Horizons, but there's other virtualization and connection brokering software. You might have heard of Leo Stream that support PC over IP Ultra. Zero clients versus thin clients. Now, these are our physical boxes that we use that aren't per se software based that you can use to connect into our infrastructure. The zero clients are a box that uses a Terra 2 ASIC. ASIC is an application-specific integrated circuit. I'm sure all y'all know. This chip does one thing, and that's Teradici, and it does it really quick. It is our best performing device and option that we have right now for both audio sync and video sync. It is limited to 2560 by 1440 at 60 FPS. It's limited to only, and it only does PC over IP. Won't do Blast, won't do Ultra. Thin clients are a really small, light OS like Linux or Windows embedded. They can install and have all the apps on them at one time since they're basically a small computer. They can do PC over IP, PC over IP Ultra, and the Blast Extreme protocols. They also support bigger monitors with these. So they can go up to 4K, but You're pulling more bandwidth the more pixels you send over the network. And here's an example of two of them that we use. So we have our little thin client over on the left. Those are actually made by Dell. They actually have a GPU built into them too. And they're pretty quick. They run a, I think it's called Stratodesk. No Touch OS, which is a really light and thin Linux-based operating system. And we have a management console that we use to basically configure all these and manage them from a single interface. And on the right are our Zero clients. These, again, they run those Tier 2 chips, and all they do is PC over IP all the time. A little bit more about imaging and how it kind of glues everything together. We use VMware's Dynamic Environment Manager, DEM. DEM is equivalent to like GPOs and GPO management of Windows. We use it as our software solution for configuring and employing all the end user and their desktop settings. It enables us to roam user home profiles around in folders as well, like their documents, their desktops, and their downloads. So it basically kind of makes a symbolic link on those Windows machines and point it to shared storage for the end users. We can also do application specific configurations for these. So if we know that we need to push a configuration file or something for Premiere, we can have DEM load that information on there for us and manage it for us. We also use it to mount some network drives for us automatically as well, taking that configuration out of the Windows layer and the Windows stack. And DEM is AD based, so we can do logic with it. So we can say, hey, this user is part of this group. They need these additional settings because let's say they are a graphics designer versus a Premiere Pro editor. Or it can also grab the geolocation of that user. Hey, I know this user is connecting into Hudson Yards. They need to map these drives instead of the Atlanta drives for storage. VMware also gives us a whole bunch of ADMX profiles. These are basically templates that you have to load into your Active Directory controllers. It's so many settings, but some of them are like the protocol settings. So we can fine tune how we want the protocol to work and interact with each and every machine from a single control plane versus managing 100 machines at one time. They also help us with our security settings, like if we want to allow or disallow USB redirection, or like our clipboard policies. So with a virtual machine, if you're running the software, I can copy and paste something from my OS I'm running it on into the virtual machine OS and back and forth if I allow it. These GPOs also are the configuration basics for DEM, and that's how it basically it checks in with these GPOs to know where it needs to find its settings and what roaming home profile storage it should attach to. Provisioning types and pool details. So there's two mindsets when you're deploying an image out. You have floating pools or dedicated pools. A dedicated pool is a one-to-one assignment. Once a user gets assigned a machine, they will stay permanently assigned to that machine until an administrator goes in and manually unassigns it. Think of this as like a pet machine, your personal machine. They're hard to manage. The maintenance, when you need to do maintenance, it's downtime for the end user or the editor. If an editor leaves or gets reassigned to another project, an administrator needs to go in and again manually unassign them. A floating pool is a many to one assignment. It creates a pool, and when you log in, you're randomly assigned a machine every time you log in. This allows us to also oversubscribe our network. So if I'm using a dedicated machine, all I could ever have is 50 users on at one time. If I have a floating pool, I can assign 100 users to it. And as long as 50 machines aren't used, one of those 100 people could log in throughout the day and use it without any more management from an administrator. This is fantastic for our departments with freelance or transient editors. It also enables us that cattle aspect. Hey, this is a hotel-based machine. If something's going wrong with it or if it's acting weird, reboot your machine and grab a brand new, fresh machine. There's also a lot less downtime since nobody's assigned a machine and they grab a random one every time they log in. And this is our design and how we are deploying the system here at Studios. We're using DL580 servers. They're 4RUs. I think they'll go up to like 3,600 watts. And we're using RTX 8000 GPUs. A little more about the hardware. Each one of these servers are 4RU. We have 12 of them in Studios alone. They're all running these Platinum 8268 CPUs at 2.9 gigahertz, which is really fast. We have 4 physical processors per server, 24 cores per CPU with a total of 48 threads per CPU. Do your math, that means we have 192 processor count in each one of these servers. We got 1.5 terabytes per server of RAM. We have 4 of these RTX 8000 GPUs in each server, and each one of those has 48 gigs of RAM on them. We have 2 Mellanox 100 gigabit per second network adapters. They are in an LACP bond, so we get a theoretical 200 gigs per second. And we have 2 32 gig dual port fiber channel host bus adapters. This is what we use to connect to the backend storage where all the VMs live. Now, Pure is what we use for backend VM storage. Now, there's a whole bunch of different storage we're about to talk about. The VM storage is actually where all those machines live. We'll talk a little bit later about our roaming home profile storage. We'll also talk about our StoreNext storage, where all the media lives that the editors edit off of. We can see here in this diagram, but they're kind of in a pair replica. It's called an active-active. So each array has the exact same data on it. They talk to each other and replicate. If something gets written to one and it's not on the other, and it doubles your bandwidth between the two. And it also allows a seamless failover if one dies or we need to do maintenance on it. Now we're using Pure. They're the FA-X50 arrays. Each one has 8 32 gig fiber channel connections on the back that we're using. It's all NVMe. The 2 arrays, total usable storage is 11.51 terabytes. On each VM, we average about 8,000 megabyte per second read and writes on these. So that's about equivalent to a PCIe Gen 4 NVMe card. Now, all the arrays are set in this active-active cluster. It's bidirectional for replication, transparent failover, simultaneous I/O, and they're replicated on the back end between the 2 arrays by 4 40 gig IP connections between the 2. Now, you might be thinking 11.5 terabytes is not a lot. I'll make this one quick. Pure has something that is called deduplication on it. It is kind of VM aware, and it talks very well with the VMware hypervisor. It removes patterns. It duplicates of data. It does inline compression for us, and does copy reduction based on metadata. So what we're seeing is we have 187 VMs. Each one of those have a 500 gig virtual drive on them. And we're only using 3.17 terabytes on these arrays. That's about a quarter of it. Getting a dedupe ratio of almost 9:1 on these devices. Now, for network connectivity on the back end, we're using 2 Ciscos. They're 100 gig capable. We have a 400 gig trunk, of course. The inner plane or bandwidth of these is 7.2 terabits per second. And we're using MVS devices to form a SAN island for our back end infrastructure for the storage. Each of these are paired, active-active. The SAN isn't on an island, so nothing else talks to the SAN or these fabrics other than the VDI systems and the storage. Just a thing to note about the MVS stuff that bit us, They only come with 12 ports license. It's not like the network switches.
I'm in a virtual meeting. Did you get my text?
Yeah, but I didn't look at. Sorry, my bad.
Don't worry. So these are the new glasses.
Oh, they look good.
Hey, Adrian, do you want to mute your mic for us?
Oh.
All right, perfect. So the other piece of storage that I talked about was our cache and roaming home profile storage. We use OpenDrives for this. OpenDrives is a massive vendor for studios. We have two OpenDrive Optimum storage arrays. This is our NAS. This is where we store the roaming home profiles and all the settings and the cache that the NLE uses. They're 200 gig backplane for each of the arrays. They're clustered and they have about 3,000 megabits per second. OpenDrives, and we use them because they have special algorithms and glue that can pre-cache Adobe footage for us. So they act really well with a NLE and editing off of them versus other storage vendors. And Quantum is our old SAN that we use. And this was a big problem for us to kind of figure out when we first started. Quantum is all fiber channel. And we can't pipe and zone out these virtual machines to the storage because it would be a zoning nightmare. Luckily for us, Quantum has something called a distributed LAN client. And that is basically, it makes a fiber channel server and it gives it a IP gateway. This DLC, the distributed LAN client, requires a file system driver to mount and manage on each of these virtual machines, but those are settings that we push out to each virtual machine. It mounts as block level versus a NAS. So you're actually writing blocks straight to the storage. Being fiber channel, it also needed a metadata network for the fiber channel on the old systems to work. That was a isolated kind of network just for the storage. That is now embedded thanks to this DLC LAN client for us. And this also gives us a lot more flexibility. So I can attach multiple SANs with this DLC software onto these virtual machines, and I don't have to zone anything up anymore. Everything's over IP now. So the flexibility that this gives us and that we went to adding these devices to our SANs pretty much makes all this possible to use all of our own old edit storage with the VDI system solution. Now, Trey, I'm probably going to switch over to you and take a break for a second.
Nope, I got you on this one, James.
Thank you.
So we're going to be talking about software deployments and basically how we manage it. So for our software suites, for our NLEs, we primarily utilize Adobe Creative Cloud. Hudson Yards, or HBO up north, one of our cohort departments, they actually use Avid Media Encoder, Media Composer, actually. Along with Adobe, we also use Blackmagic Resolve for a lot of the colorist out there. The plugin suites we primarily rely on is Red Giant or Maxon, and then we also use a plethora of Boris, Sapphire, AE scripts. Any of the works, we can deploy this just like a regular system. We also utilize C4D for certain 3D elements that we are starting to put into what's called toolkits. For our type or our font management, we're using Monotype. And then we do have a very large asset and project management system. We use Strawberry for that, IPV. We use certain elements for EVS, and then we're also constantly exploring more means of managing all of the millions of assets we have. We do separate our backends, so we separate sports and entertainment, both for high availability. We separate that for performance, and then also that separates the downtime requirements for each of the departments. So we won't have to go and take down the entire company to do maintenance on just one subset of systems. We also utilize a lot of custom scripting that allows us to switch the workflows and to switch the storage and to also switch over the asset management systems for the users. With this as well, we use a lot of DEM, which allows us to do that based upon AD groups. Flexibility and ease of use. This allows us to use, with VDI, we can, what James mentioned is app streaming and then other types of legacy applications. We're able to create these pools with primarily for these legacy systems, and then they would not affect anything currently in production. So legacy Firefox, for this particular case, we spin up a custom VM pool with just that. And obviously with a non-modern web browser, you really can't do anything without updating that. So when we can force that to never update and then still maintain this legacy system while still not affecting any of the other production systems. With VDI also, we're able to beta and SAT and UAT test new software releases without also affecting any type of production systems. I can spin up almost an endless amount of dev machines without actually buying any new hardware. Like we used to with the Macs, we would basically, if we wanted to have 10 users test, we would need to go find 10 dev Mac Pros that are laying around somewhere, re-image them, and then build them up, and then start testing. And once they're done, they just sit there. But now with VDI, if I needed to test 20 users, boom, I can spin up the 20 users in 15, 20 minutes, and then when they're done, just delete them. VDI allows for us to basically rapidly deploy machines at our will, and also we can what we call burst more machines, which is if our department requires, they have a lot of freelancers and it's the busy time, most likely it's sports, and they require 30, 40, 50 more machines or editors on site or just working. It would take us about 15 to 30 minutes to end up creating all of those machines. And by the end of that, they're ready. And let's say they're only working for a week. Then we basically delete them to regain those resources back. We use, you guys might be asking, what about licenses? And how do you guys manage a lot of that, especially considering you just said resolve? We utilize what's called the SCH UTN manager. It's that's the software behind it, but we have these dongle servers that sit in our racks, and they're literally USB to IP extenders, I guess. But they basically will show you off any of these licenses that are plugged into those USB ports, and users are allowed to check out those licenses, and then they can deactivate them to put back into the pool. This manages expenses by just allowing us to purchase 40 or so licenses, and now they become a part of a floating pool of them versus handing them out to all the editors. We break down our software maintenances basically into what's called two separate categories: major updates and then minor updates. Major updates would be those that we would do operating systems, Adobe 2023, 24, etc., and then GPU drivers. These major updates are more widespread and they require system downtime. They're basically, we will update the base image, test that prior to release, and then we will release that by creating new pools for users to actually jump on. Minor updates are what's called update in place, where we can push out these softwares using our tools, Goverlan, SSPM, any type of scripting, or even manual installations if needed. And then once those are out there into the public, then we update the base image on the back end so that future provisionings or machine rebuilds will get that update. For system monitoring, we use a couple of tools right now. We have Control Up, which has direct insight on all of the machines within the VMware and ESXi infrastructure. This gives us in-depth information from the machine, such as GPU, CPU, RAM, network, and a lot of other details. And the nice part is this is all done in real time. One of the biggest metrics that we look at from a remote perspective is latency, packet loss, and then bandwidth use. This is very good because we want to know if Jane Doe has really bad internet, and that's why, they're getting really bad performance. This also gives us a little bit more in-depth detail as far as how many concurrent users we have editing at the same time. And then what we like to label as time spent editing. This gives you exactly how much time is spent in certain applications versus other applications, so that we can see if there's any type of improvements we can make that will, in turn help the editors be a little bit more efficient. For our software management, we use Goverland to. This is a little tool. It's very. It's nice. There's an agent that gets pushed out to the systems. It allows us to get basic information, but also the biggest part is it allows us to run custom installation scripting so that we can do rapid software deployment on the fly. We use Grafana and Prometheus to monitor the UAGs and connection brokers, as well as other Linux machines. Gives us a nice graph and monitors all of those metrics, and gives us pinpoint time of when we can see spikes or blips in certain network connectivity. And then I think we're just going to jump straight into the demo right after this. So I will jump over. Let me share a different screen. Let me know if you guys can see that screen now.
Yep.
This thing over. So this is going to give you a little demo of how the Horizon client from a software client goes. Gives you basically 80% of there. We can't show you the thin clients, just it's a little bit more difficult to get from the user perspective side. So when I load up my VMware Horizon client, I get my load of selections of servers that I can add. We'll go ahead and connect in here. And this is the same experience how our editors would actually come in. They would enter their username and credentials here. Let's actually do this one. They would enter their email address and password. They're going to get a little buzz on their phones for Okta, because we always implement 2FA now. And they'll enter this again. Now they're NT creds. We now see a bunch of pools here, and I am in the engineering group, so I see a lot more than our editors. They would typically only see something along the lines of this, where they would only get a handful of pools that they are authorized to go to. We'll jump in our testing one. It's going to act weird on me because I just did a screen. All right, this is on my end. I don't think I'd like to zoom on that. Let's do this. Display one large window. There.
You can see right here, this is loading the DEM policy. So this is making any configuration settings that Trey might have had. It's applying it to the machine, and it's also mapping his shared folders, his roam and home profile, and whatnot during that process.
And once you get connected, it's basically a regular Windows computer. The scripting is going to start loading. Everything loads up pretty quickly. and we can see our lovely monotype comes up. I'm just going to close out of that. But if we go into the system, we're now basically ready to go. This is a floating seat, so I just grabbed a random one that was available in the pool. And if we go look, we're giving everybody 64 gigs of RAM. They've got themselves 18 cores that are allocated to them. They've got their GPU here with 8 gigs of VRAM. And then basically your other types of suites here. So we've got our basic Adobe suites here and DaVinci Resolve if we want it. This is our UTN manager that allows us to check out dongles. So we have a bunch of Resolve Studio licenses available for anybody to grab. And what we're going to do is, James and I just wanted to bring up how quickly you can get into, Premiere. So this is my first time on this particular machine. With that, anytime, for anybody who's familiar with Premiere, the first time you open it, it has to load up all of the plugins. And we probably have about 300 or so plugins that we distribute out to all the systems. So it does take a little bit longer than if you didn't have any plugins to start.
Now, all this is loading. So these machines are internal to our network as well. You don't need any VPN access when accessing externally. We tell the end users, do not under any circumstance, if you're connecting to VDI, use the VPN. If you need to access internal company resources, just use the built-in apps on the virtual machine here. It's going to be just like, since it is in the building, it's going to be like working from the building. You don't need any special credentials or anything, and you can access all the internal web pages if you just bring up like Chrome or Firefox or Edge and do your work per normal. Trey's actually, you've been adding webcams to these, I think, starting soon, so they can do their Zoom conferencing right from the virtual machines as well.
Correct. There's some, with the thin clients, there's all these integrations that we're able to leverage. So the next one we're going to implement is leveraging full HD or potentially even 4K webcams and also external, not necessarily audio interfaces at this point. It may work, but we haven't tested it, but definitely like snowball microphones and everything. Those will integrate directly into Zoom or WebEx, your flavor, so that you can get very high quality audio for your meetings and webcam. We have a project here, and at the same time, this is, it's when you want to see, it's basically regular Windows, and we can see how high the quality is. I don't know if it's showing well over screen sharing.
It looks great to me.
Zoom, but we can go to YouTube, you can do your normal things, and the video quality that you'll see here is almost like if I were on my regular computer, not virtualized over here. So we have a project here. This is one of our editors, quick one that they did. There's probably some media missing too, but I'll play this real quick. Change that to full.
And that's the beauty of it too. It's a full-featured editor instead of something like a Media Central from Avid, where it's kind of a lightweight editor. We give the artists and the creatives all the tools they were used to using with the same exact experience as they were editing on site. So they'll have, again, like After Effects when they need to do some composition type work. DaVinci Resolve for when they need to do some color grading and whatnot. They haven't skipped a beat.
Yeah, and the we kind of, after trial and error throughout our times, it's we've gotten the system extremely stable enough where editors can go back to their bad workflow days. We can go over here and just I can scrub through this like a madman, and the system's still good.
Yep.
So
And
it's very stable.
from a customer aspect, I was talking to one of our tech leads today. He wanted me to make sure I mentioned this. It enabled production to do things they haven't ever been able to do before. They're now able to hire these freelancers outside of the Atlanta region. So they have freelancers working in Italy and all over the country now that can get into these systems. And now their creative pool for editors has just exploded on what they can do and who they can hire and how these people access these systems to edit content local to Atlanta and being ingested in Atlanta. And Trey's going to pull this up.
I think yeah. Here's our normal storage, just like how you were. James, did you want me to pull up something specific?
Yeah, I think it's good at this point. A quick little example of how it works. It's pretty quick, other than the plugins loading, which ain't nothing you can do about that, Trey.
Well,
it's still pretty quick.
Technically, after it's loaded already, it's super quick after that. But
yeah, you'll see after he opens this one up, it takes less than 10 seconds to open up normally.
Yeah, and now it's going to come up. There you go. So about 10 seconds or so after the first one. And that's just the nature of Premiere. It's the same thing for anybody who's familiar with it. When you close out of your preferences and everything, it has to cache all that. I think we can probably move on to questions and answers.
If I can, I've got a couple questions for you. Number one is, I see that you said that you do H.265, which is HEVC. Is your equipment able to handle it? Because that's a lot of processing.
So these the graphics cards we have in here, Jack, are the RTX 8000s. They have built-in encoders directly on the graphics cards made just to do that for us. That won't affect the actual GPU performance utilization. I wish I had a diagram of how that looks like, but we got with our NVIDIA reps to figure this out with them. And you can toggle it on and off. Trey, do you want to close out of that pool real quick and go back to the client?
Yeah, let me.
Oh, I believe you that it'll do it. But you also mentioned, I think, these 8000, or what was the machine?
RTX 8000s.
580s or something?
RTX 8000s.
Oh, the HP machine.
DL580 Gen 10s.
Did you actually say they can draw 3,500 watts or 3.5 kilowatts each?
Yep. So we actually are running dual 60 amp circuits to each rack to support these.
Actually, the thing that worried me more was the cooling.
Yes. On a nice cold day, it's one of my favorite places to go warm up.
Yes, it's
how many of these do you have in a rack?
I want to say we have 6 per rack plus the network on top of rack switch.
Yep.
And I think we isolate the storage, one on each rack as well. And the open drive storage is in its own.
So
rack.
I assume cooling is something like the speed of a jet engine.
It's
actually not that high, Jack. Surprisingly, so most of the heat load is coming off of the GPUs.
Yep.
From a processor perspective, and a like the actual system fans for the servers, they're running at like 30%.
Okay.
Yep.
They're larger since it's a 4U. They're using larger fans instead of those. If you're familiar with like the 2U servers, those little thin ones that run 40 mil and 60 mil fans, they're just screaming at 15,000 RPM. These are, I think, they're spinning at like 4,000.
What about the client and the networking for the client? What are the demands for that? It sounded like you've gotten the networking for the client very low, or what the client has to be able to do very low. But what is the minimum networking you can run to the client? What's their connection have to be?
We have some editors that are running AT&T DSL that happens to be at about 5 megabits per second down and less than 1 up. I'm not going to name the names, but we all know internet is not very so depending on the client. So if you're using the zero clients, those Amulet hotkeys with the Terra 2 chips that only run PC over IP, it is much more bandwidth demanding, just because of how it handles latency, more or less worse than the software client. So with the software client, we've seen, that editor, he's able to work every day. It's not the best, but for 5 megabits per second, he's getting, great performance.
Okay.
That said, Jack, we recommend 100, at least 100 megs for it, and we pretty much demand you need to be hardwired connection with an Ethernet cable to edit with. That helps us as engineers kind of lay a ground and a framework to help us stop troubleshooting so many network issues. Sorry to step on you, Trick.
Nope, all good.
So the rest of the people, who's got some questions?
I have a quick question. You guys mentioned for people using thin clients, do you have any users that, you mentioned that they could use external monitors. Do you have anyone maybe using DaVinci Resolve with a professional reference monitor over SDI?
We're still working on those solutions right now. That's those kinds of external monitoring. That's one of those never-ending battles. As technology continues to progress, we're still exploring. There's not a very great answer and a solution, unfortunately. I
want to say we're more in step internal with NDI in decoding it.
Yes.
Than external.
Gotcha. Yeah, that's kind of what I found as well, is that, as much as I want to just, have PCIe slots on the thin clients, you don't get a bunch of room to shove a big SDI card in there or something like that.
Yep. And I'll speak to our HBO counterparts to a degree. They have AJA 2110s in their VDI system. That makes their management of their VDIs back to that cattle versus pet thing. They can't virtualize these 2110 cards that they have in their infrastructure. So they have to have downtime and maintenance and all the router stuff. But that's how they're sending those that reference signal out to the broadcast monitor so they can color grade more accurately.
And is that internally at their facility?
Internally.
Okay, yeah. Yep. Awesome. Thank you, guys.
Mm-hmm.
Other questions? I'm going to tell you, James and Trey and everybody, that I'm going to take a lot of time to just absorb this.
It's a lot. It was dense. There's a lot to cover. Me and Trey are more than happy to answer questions or give personalized demos too, if anyone's interested or want to get more in detail or in depth.
We're going to work to take this recording and get it up for everybody onto YouTube. Also, we're going to try and get James, take your PowerPoint, make a PDF, and we'll try and get that up on the SMPTE website. So you're muted.
That's perfect. Thank you so much, Jack.
So we'll do that. Reminder to everyone, you're going to be getting, if you're a SMPTE member, you're going to be getting an invite to our party in December, which is a fantastic party at Maggiano's at the Cobb Galleria for you and a guest. It's paid for by our sponsors. If you are not a SMPTE member, now would be a great time to join or renew. If you have any questions, please feel free to contact me on that. So that email will be going out shortly. I want to thank everybody for coming out and thank our presenters.
Good job, James.
Yep. Thank you, guys. Appreciate y'all.
Thank you, everyone.